Alright guys, welcome to the channel, and today I will show you guys how to install Fedora CoreOS. The installation process is a little different from standard Linux installation, so there are a few things that you need to keep in mind. In order to install Fedora CoreOS, we need to provide it with an ignition configuration, and that is in the JSON format. In order to create an ignition configuration, we will first create a Butane file, which is in the YAML format, and then we use the Butane utility to convert it over. Now, to install Butane, you can use Docker or Podman, or you can use your operating system's package manager, which would be easier. In my case, I'm using macOS, so we will be using Homebrew for this. It just brew, install Butane, and that's it. As you can see, I already have Butane installed, so I don't need to do anything more. After that, we need to take a look at the Butane config. Now, this is the bare minimum. Here we have the variant being Fedora CoreOS fcost, and it's creating a user named core, and then we specify the SSH keys there. A thing with Fedora CoreOS is that even if you do not specify the core user, they will still get created, just without any SSH keys. And this is the bare minimum to get started. I have created a set of CoreOS Butane files first to use, and it's a little bit more detailed, so let's have a look at that. You can find it on my GitHub account by going to GitHub, TommyTran732, and search for Fedora CoreOS Ignition right here, and you should find it. I'll be opening it in VS Code, so it's easier for us to go over. Alright, so here you can see that I am creating a user named Tomster with my SSH keys down here. Now, when you're making your own deployment, of course, change the username and the SSH keys, because you wouldn't want me to be able to log into your servers. Obviously, the groups I'm creating, I'm assigning myself to, are the wheel group and the sudo group, because that is what the core user is actually assigned to, both wheel and sudo. It's a little strange, but for myself, I'm doing the same thing, assigning both of these groups to myself. Now let's go over the systemd units that I have created. Here you can see the post-installation service. So this service will run after the OS has been installed, because not everything can be done within the ignition configuration, or it may just not be convenient. So that's why we create a systemd service to do it afterwards. It only runs once, and it checks for the whether this path exists or not. Obviously, after it runs the first time, it will make a timestamp, and then it will not run a second time. So it runs the first time after the installation, and that's it. These are just standard configurations. Here you can see rpm-ostree overlaying the QEMU guest agent. So basically, we adding the QEMU guest agent package on top of the Fedora CoreOS installation. This is for a virtual machine made with QEMU KVM. Obviously, if you're not using QEMU KVM, you're using a different hypervisor, or you're doing bare metal installation, you can just remove this because you do not need it. Second line is the override line, where I remove packages from the base image of the OS. Most of these are just remote file system that I'm not using, so I don't need them. I remove them. If you're using them, then just remove this line, or just remove the package that you actually need over there. Down here you can see that I'm pulling the kernel module blacklist and the sysctl hardening configuration from kicksecure. What's interesting about the sysctl configuration from kicksecure is that by default it sets yaml ptrace scope to 2, meaning that only admin processes are allowed to use ptrace. Now, if you're not using gVisor, I would advise that you set this to 3, because you probably wouldn't have any processes that needs ptrace. So just setting it to 3 to disable it completely would be better for security. In my case, I'm using gVisor, so I have to set it to 1 to allow every process to run ptrace, because that's what's needed to run gVisor. The next 2 lines are just to not ignore ICMP echo requests. Kicksecure disables that by default for privacy or anonymity reasons, but this is a server, we don't really need that, so I am replying to ICMP. This one is an interesting one, the crony configuration. By default, Linux, especially Fedora, uses NTP for time synchronization, and that is unauthenticated and unencrypted. And it only defaults to using 1 pool, if I remember correctly. Don't quote me on that. But it is very insecure by default, so I'm using a better configuration. I'm pulling this from Graphene's OS infrastructure, and let's have a look at that. Basically, what this does is that it uses NTS instead of NTP. So first of all, we have encryption and we have authentication. Then you can see that we're using 4 different pools for time update, and at least 2 of them have to agree on a time update for us to get a new time from our server. So let's say if a pool turns malicious or gets hacked or whatever, they cannot force a time update on us, because we need at least 2 sources to agree on that. So this is a pretty solid configuration, and I recommend everyone using something similar to this. Okay, let's move on. This is just minor systemd hardening from the brace package from divsOS infrastructure. Nothing too crazy to go over. And here you can see that after everything's done, it makes a stamp, then it reboots. After the reboot, you'll run a second installation, post-installation process. You may need this, you may not want it. It's up to you. It doesn't matter much. What this does is just it sets up the Watchtower container to update my Docker containers. This is a very simple setup, so nothing fancy, so I have to use Watchtower for it. Obviously, if you're using something else, or you're doing Kubernetes and whatnot, and you have your own method of updating your containers, just remove this service, because you wouldn't need it. One thing to notice is that I'm using the runsc runtime right here. This is the default Docker runtime instead of gVisor, mainly because if you're allowing access to the Docker socket with gVisor, it's just going to result in a permission denied error, and we wouldn't want that. So let's move on. Next we have set SEBool service. Now this is basically setting temporarily SELinux booleans every boot. And why are we doing that? Well, turns out Fedora CoreOS has an issue with SELinux updates. Let's Google for it. Fedora CoreOS safe SELinux update. And here's the issue that you can find. Basically, the problem is if you make a change with the SELinux policies, OS3 will stop updating the policies with each Fedora version updates, and that may result in issues in the future. So we wouldn't want that. So the workaround right now is just to apply the modifications temporarily every boot instead of making it persistent, which is what I'm doing here, as you can see. I am basically disabling CephFS, NFS, and Sambas for containers because I don't use any of them. Obviously, if you do use them, just remove these lines, or if you don't want any of the changes, just remove the entire service altogether. That is fine. gVisor updater service. This is an interesting case because gVisor is actually available in Fedora CoreOS. The problem is it is 3 years out of date as of this video. If you look at Fedora CoreOS, Fedora sources, and if we have a look at Golang's gVisor right here, oh, that's a typo. There we go. It has not been updated since November 2021. That is not great. That is over a year out of date at this point. A year and a half out of date. Not ideal. I do not recommend using this package. Instead, we will get gVisor directly from Google right here. So this systemd service, it runs every boot, and it runs before the Docker service goes up, and it is the equivalent of these commands right here. So it just gets the latest gVisor version from Google, put in there before Docker starts, and then Docker starts up, it uses the latest gVisor version. That's all. Other stuff, simple, just enable the Docker service, enable ffstream timer, systemd omd. RPM-OS3 count me, it's just telemetry for Fedora to know how many RPM-OS3 systems are running. I just disable that because I do not like telemetry. This is just changing the SSHD service to the socket, so I'm using the socket instead of a service. Doesn't matter much. It's a preference thing. Okay, this part is important. We're going to the storage. So after we create we have created the systemd service. We're just creating files, configuration files now, and the important thing here is the update strategy. As you can see, I'm using the periodic update strategy, and I'm updating every Sunday at 12 a.m. Very simple update, and great for small installation. There are two other update strategies that we can go over right here. One is the immediate strategy, right? So what does immediate does? Immediate means, hey, if it sees there's a new update, it downloads the update and reboot the system immediately. The periodic strategy that we are using is basically see the new update, download the new update, but not rebooting the system, and waiting until the scheduled maintenance window, then reboot the system to update the system for real. If you're doing a large deployment, you should look at the lock-based strategy instead. Basically, we have a control server, and then all of the client servers running Fedora CoreOS look at the control server and see, hey, am I allowed to update yet? And when you want every server to update, you update the control server. That's it. This is more suitable for a larger deployment. But yeah, since we're doing a simple installation right here, I'm using periodic. Tuned. This is for performance tuning. I made this for my virtual machines, so I'm using the virtual guest performance profile. Of course, if you're using bare metal, you probably should set it to latency performance or something similar. Okay? ZRAM. This is an interesting case because Fedora CoreOS by default does not ship with swap or ZRAM configured. And that is probably because Kubernetes does not like swap and ZRAM. If you're using Kubernetes, you should not use any of these. So on a Kubernetes installation, on a VM for Kubernetes, just remove these lines. But here I'm using regular Docker containers, no Kubernetes, nothing like that. So I'm enabling ZRAM. This is an interesting one, unbound configuration. Basically, on Linux, by default, there's no DNSSEC validation. And if you're using something like SSH fingerprint or checking text records or TLSA records and whatnot, you will want DNSSEC validation to make sure that, hey, the response from the upstream server is valid. Here, it's just a hardened unbound configuration, acting as a forwarder to Google DNS over TOS. So it's a pretty secure configuration. Obviously, you can change Google to a different provider like Cloudflare and whatnot. Or you can configure unbound to do DNS resolution itself instead of being just a forwarder. But that's up to you. The main thing here is that we're validating our DNS queries, DNS response by doing DNSSEC validation. Okay, this is basically a bit of systemd hardening from the unbound package. This is in the unbound documentation and is included on Arch Linux by default, but for some reason Red Hat and Debian do not include them, so you have to add them manually if you want the systemd hardening configuration. Okay, this is the Docker configs, and here you can see we have two runtimes defined. One is gVisor ptrace, the other is gVisor kvm. Since I'm running in a virtual machine and I'm not doing nested virtualization because that's extra work, and there also is security implications with nested virtualization, I'm using the ptrace platform. Obviously, if you're running this on bare metal, I recommend that you switch this to the kvm platform instead. You would get much better performance that way. Or if you don't like gVisor at all, you're like, this is too complicated for me, too much effort, you can switch back to using the default Docker runtime, runsc, by specifying it there, like that. One thing to keep in mind is that I'm specifying the network host flag right here. This is because gVisor uses its own networking called netstack, and that breaks DNS resolution with user-defined Docker bridges. If you're using Kubernetes, do not specify these flags because it actually reduces the isolation that gVisor provides, because now we're using the normal Docker networking. So it's only there because this is a normal Docker deployment without Kubernetes. But yeah, that's something to keep in mind. Kubernetes, just remove these lines like that, and you should be good to go. These are just links that we make on our system. Nothing too complicated. Just making sure that the servers are enabled by default. And here's the kernel hardening arguments. I mostly got this from Kicksecure. Obviously, the target platform here is x86, because we have things like spectrum mitigation up here. If you're not using x86 and you're using ARM or something like that, you can remove most of the spectrum mitigations because you do not need them. Also, these kernel parameters will disable hyperthreading, because that is responsible for a lot of vulnerabilities. If you don't want hyperthreading to be disabled, just look for the no SMT flag and just remove them. Yep. And we should be good. After you've made your Butane file, we will need to create our ignition file, and you can see right here that is pretty simple. So all you do is you type butane pretty strict blah 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 generic YAML doing generic .ignition. The documentation says use BE for the butane file, but it doesn't matter, it's just a YAML file, just like that. And if you look at the ignition file right here, we have our JSON file for deployment. The pretty and strict flags are actually optional because you can go without them, and that would just leave like a very unformatted JSON file. It looks like that. It's up to you whether you want it to be pretty or not. It really doesn't matter. A few things that I do not put in my configuration. One is encryption, because here I'm setting it up on a virtual machine and the host is already encrypted, so I don't feel the need to encrypt the individual virtual machines. Obviously, it still might be something that you want to consider. So look through the documentation right here. You have to set up clavis with a pin, either the TPM pin or the tang pin for root file system encryption. The TPM pin really doesn't make sense for a virtual TPM because the TPM is easily accessible. So it's better for a virtual machine if you use tang instead. So that's something to keep in mind. And now all we need to do is we need to set up our VM. Here I'm using an ISO file. You can use the QEMU file and then pass in the ignition file like in the documentation. Let me show you guys. Provisioning, booting on QEMU. You can do that. Just pass in the path to the ignition config right here, and then run it with QEMU. One thing to keep in mind is that you have to configure the network in the ignition file if you do so. So you have to go to the Butane config and specify it right here. Especially if you do not have DHCP. If you have DHCP is fine, but if you don't and you want to do static IP configuration, you have to do it within the Butane config. That's a little bit less convenient in my opinion. So what I personally do, I just boot up the ISO right here. Then I configure the network using nmtui and just edit a network configuration, and that I've already filled in my static IP address configuration right here. But you can specify your own according to your network. Once we're done, we just save it like that. Don't bother setting the network hostname because that's not going to persist. Now, all what's left is us doing the installation. So we do sudo. Actually, before that, let's check our devices, list block devices, and we can see that the target device that we're using is SDA. So we do sudo CoreOS installer. Okay. what do we do with the installer? We install. Where are we installing the system? Def SDA, as you can see up here. Now this is very important if you're doing an installation from an ISO like I'm doing. Just pass in the copy network argument, because we want it to save the network configuration. Otherwise it will not do that, and then you cannot log in, and then you have to boot into recovery via VNC and then fix it. It's very annoying, so it's better to do it this way. And passing in the ignition config. Now if you're on bare metal, you can put the ignition file inside of a USB stick and just do ignition file like this, and then specify the path to that file. Here I'm just using the network URL. It's more convenient. Ideally you should be using your own server, your own little trusted server for the ignition file, but I'm being a bit lazy here, so I'm just gonna use GitHub for that. Obviously it's not as good, but it works for our purposes. I'm going to use the Docker Compose ignition file instead of the generic one. There are only slight differences that I won't go over here, but that is the URL that we need. Okay, so let's type that in here. https raw.github.com/TommyTran732. That's my username. Fedora CoreOS ignition, that's the repository, main branch, and the file is called Docker Compose ignition. Oh, my bad. We made a typo somewhere. There we go. We need caps in the file name. And it's installing, and it's doing that really quickly. And while we're waiting for the OS installation, there's something that I have to mention. There is a bug with the latest gVisor version 2023 0320.0. There's a bug with it causing gVisor to fail to run with SELinux in enforcing mode. It works fine with the previous version, so for now, temporarily, until this is resolved, I recommend that you disable the gVisor updater service. Let's look. I recommend that you disable this after the OS is set up, and then you replace the runsc binary with the previous build, which is let's see here, text 2023-03-13.0. That's the version you should be using just for now. Hopefully they fix this in the future, and then we can just get automatic updates with gVisor. And you can get that by just going to the gVisor documentation right here. Look at point release, and just follow this URL. And that's it. Okay, let's see what's going on with our OS installation right here. It's finished. So let's reboot. And it will reboot twice, and you see. Okay, first time rebooting. Booting into the system. Now it's running ignition. So ignition is doing its job to configure the OS. So let's just wait a little bit for that. It's done. Rebooting the second time. Oh, and I lied. It actually needs 3 reboots. not 2. Anyhow, it's booting into the system right now. And usually this is the end of it. But remember, we have this post-installation service right here. And it's applying its own changes to the OS again after ignition is already done running. And by the end of it, it's going to issue another reboot. So you have to wait for that. After that's done, you can use the system like how you would want to. And that's it for the installation process. And I hope you like it. I hope you find this helpful. And if you do, please like and subscribe. If not, you know what to do. I'll see you guys next time.